again, my colleague John Wheeler would like to be here. He's teaching, unfortunately, at this time. So I present this one. It's some work we've done together. So again, it's more of a focus on teaching computing and using digital technologies as part of that. So it's relevant to the e-learning theme in general. So we're talking about some approaches we have here at Hull as part of a curriculum review. I mentioned that again in the early talk around when we looked at how we embedded ethics in our courses. But at Hull, we've moved forward from our kind of traditional learning objective-based education to institutionally an approach on what's called competency-based education. So it's, in some sense, you can say it's a more of a semantic change. So learning objectives are traditionally how we talk about the outcomes of education at all levels. In higher education, that's been common for a couple of decades now in the UK. But there has been a move, again, particularly in the last 5 to 10 years, more towards competency-based education. You see that a lot in systems like nursing, where you want your nurse to be competent. All the nurses should be competent to do the job they do, or doctors should be competent to do the job they do. It's not so much about a grade or what learning outcome they achieved, but can they competently look after you. In computing, that's also been adopted more and more. The ACM standards for computing curriculum, the QAA benchmarks here in the UK, and the BCS do mention competencies to lesser or greater extents, although they still tend to frame it in terms of learning outcomes. We move towards a competency-based one, so that our students should show they are competent in various aspects of being a computer scientist or software engineer or games programmer. And as part of that, also a spiral curriculum, which is the idea that students meet a topic at one level. As they progress through their course, they meet it again and again, becoming more specialised and knowledgeable on that topic. And again, the spiral curriculum is quite a well-known model. If you search around and have a look at examples of it, I think one of the common examples is teaching programming. Again, we talk about the idea that you might in a level or year 1 or level 4 course, you might teach basic concepts of programming, and in a second year more advanced programming, about a third year of applying it to build bigger solutions. So that's seen as a good example of a spiral curriculum. So the approach we have, how we would develop skills and knowledge and competencies in our students, and alongside that, how we would do that to give them the very sort of transferable key skill, which we call core skills, of working in teams and doing group activities. So this talk will look at some examples of that. We had several decades here at Hull of doing team-based projects and doing it in a structured way, and in particular using web-based tools, so e-learning, such as WebPA, to help us manage that process. Again, I'll talk about why that's helpful. We'll look at how we changed that in the last 2 years as we've adopted a tool called Buddycheck, and how that can help students in looking at their professional development as team workers, working in groups, because it can give them things like a skills profile of what they've done. I think how that creates some new challenges when we're looking at that, and how you can preempt and avoid problems and student disputes when using team projects like this. So why teamwork? Again, well, it's a key competency. So like I said, a theme today of things we should teach our students. So teach them AI, teach them ethics, and teach them how to work in teams. So that's another thing which we should be doing for computing graduates. The QAA computing benchmark mentions the need for this. Teamwork is encouraged in courses. Again, the BCS accreditation guidance talks about students should learn to contribute fully to work with teams, demonstrate ability to work as a member of a development team, and recognise different roles in a team. But one thing you commonly see in practice, particularly in education and particularly in university education, is that organising, monitoring and managing teams and team assessment can be a challenge. And particularly when it comes to giving students a mark at the end of the day. So whilst we want to be competent at working in a team, we also often want to then grade them beyond that to say how good they are in that module. And with team activity, that can be seen as a challenge. And the easy get out, and many many places have done in the past, and colleagues still do, is to say, well, we'll just do teamwork in the first year, level 4, and we'll only do it we'll give students a team mark, and that will be the end of it. But you're not really then developing that competency as you go through the course. And it does mean you have the problems that we'll talk about in a moment. So here at Hull, the competency-based framework is there to help students learn to be aware of what they're doing, so self-awareness, to understand the content we teach them, the knowledge management, and to develop the ability to go off and be a practitioner in whatever discipline we're doing. So a disciplinary professional experience and knowledge. And that's all within this sort of diagram here, this disc. And around that, you've got critical independent thinking, digital literacy, knowledge management, self-management, leadership and collaboration and communication. So we have these different concepts to integrate our course. And within our computer science courses here at Hull, we thought we do that by having a team worker. So people would develop a competency to work and communicate as part of the team, to think objectively on how we contribute to that team and the natures of leadership within that context. Also to be a self-aware learner, so they can understand, document and maintain a portfolio of evidence to demonstrate their commitment to lifelong learning. So again, it's preparing our students as undergraduates to go on to the longer term careers by ensuring that they start to develop these competencies early on in their studies and maintain it throughout the levels of their studies. So competencies at Hull are met usually at all the levels of study. Through spiral curriculum, they develop more and more specialised applications of it as you go through the course. So when they finish their degree, we can say, this is a competent computer scientist. They are a competent software developer. They can create competent solutions. They understand how to work in a team competently. And you see the kind of idea of developing this competency framework. We designed that in our course at Hull with a set of modules. So this illustrates it for a typical student. So this is our software engineering type program. So teamwork is a competency. There's elements of team roles throughout the course. We develop this sort of behavioural understanding traits and needs and practices, and we apply that as we progress through. So, for example, in our first year, we have a professional development module I teach along with John Whelan. He covers some of the teamwork activity in terms of the team projects we work on. I cover some aspects around understanding how we document and evidence things. In the second year, level 5, university framework in the UK, they have a module on design, develop and deploying a solution. Again, done as a team. So that's a 40 credit module that all the students do. They work in teams, typically between 4 and 6 students, as a software developer, effectively, building that competency. And then at level 6, we have a digital disruption and innovation module where they go on to utilise that and use it in practice. And then at level 7, if they go on to the master engineering version of a course, we have a commercial development practice module where again they work in teams on problems brought to us by external partners, working as a commercial team, where again they're developing that competency. So throughout the course, they meet it repeatedly. So that's that spiral concept. At any given level, they'll have met the ability to work in a team. And so we have that as a core thing throughout, which means we have to grade it, particularly grade levels 5, 6, and 7, where it counts towards the degree classification. Now, how do you approach teamwork? Well, again, there are many ways to do that. And again, it echoes some of the discussions earlier this morning around how you might assess in the age of AI. But the original approaches would often involve things like a Viva or interview of the students in a team. You talk about what they did, decide on the contributions, you maybe observe what the team was doing, and grade that. And that works with small numbers of students. So when I began my teaching career, computer science at the time had about 50 students in it, and the module I was teaching on had 20 or 30 students in. I can manage teams quite easily at that level. I could work with the 5, 6 teams I had, and it was fine to do that. They could fill in paper forms of contribution. I could talk to the teams and work out contributions that way. However, as numbers increase, that becomes harder. More auditing transparency are needed. So fact-based methods could work to a level. So students might hand in a form where they agreed on the proportion of the final deliverable, so the report, the software, the database, whatever they made, which they'd all contributed to. Again, there's some issues with that sometimes about them agreeing on actually what proportion we all did. Often they would all just agree to give each other the same proportion. But again, that works okay. We've got smallish numbers. It starts to break down if students aren't always there to fill in the forms, if there's issues with relationships, and even managing the number of data you get. So if you've got 150 students and you've got 15 teams, even of 10, that's still a lot of data to start collating and managing. So in the sort of mid-2000s, with tools coming out would help with that. One of the early ones was a thing called WebPA that was developed as a GIST project by University of Loughborough and University of Hull. We developed that as a way to gather data on teamwork activities, and it had an algorithm built into it to give individual students a personal mark based on the grades they gave each other on that project. So you could say to a team of 5 students, create a software project that will give a user interface to this database and write a report on what you've done. Then you monitor the teams for a couple of months. They hand in the report, the software, you mark it, you have a mark for the team. They go to WebPA and we mark each other's contribution. And that then gives them an individual grade based on what they've done. So it gives you a level of transparency, data gathering, and it's quite scalable. I used modules of 300. It was quite manageable. So I use various algorithms to rate these students and give you marks. And address sort of problems that students complain about in team projects. It lets them identify people who might have been called freeloaders, who don't contribute much or at all. It means people who do a lot can be recognised and get a higher mark than the team got. And they should deal with all the sorts of fairness and transparency issues which team projects can sometimes create. So these are where we have these mechanisms that give individual marks based on team activities. If there's student work and staff concerns about group work, so it can engage more students because they see they have to engage to get marks. It addresses that issue of preloading, as I mentioned. Rewards for those who contribute more, and it's perceived as fairer, which is where team projects can fall in otherwise. So sort of general approach to that, you set up your team activity, the team develop their deliverables, staff mark the outcome, the students do this score and grade for each other, and that score is then used to generate an individual mark. Again, usually there's a separate part of that where students who have concerns or teams have problems could ask for a team viva, where I then talk to the team, 5 of them, and understand the problems. And again, having done that for well, sort of 2 decades with thousands of students across multiple modules and many teams, I only have had one team ask for a viva. They don't like having vivas, so they'd rather do it impersonally on web form and accept the outcome than ask to defend themselves with a member of staff to explain why they think there's a problem. So it meant that they couldn't then complain about the outcome. They had a chance to, but they don't choose to because they understand the process. So you can preempt the problem by being transparent at the front, but do give them a route out of that if they do want to challenge what might be the outcome otherwise. So WebPA was very positive in terms of it was a well-established approach. It's got known published algorithms and is easy to use. A few negatives about it though. It's rather dated now. So it was designed in the mid-2000s. HTML web pages design was simpler back then. We have a campus VLE called Canvas, and it has weak integration with that. A little feedback to students beyond the marker profile. Another positive for WebPA, and again, it's still there if you've not heard it before, used it before, is it is free. I think we discussed with the talk of networking about availability of systems. WebPA is on GitHub. You can download it for free. You need a web server, you need a database, some sort of development environment to run it in, but it is relatively easy to set up and run. As student projects where they set it up and run it on a Raspberry Pi. So it's quite a nice tool, but it is a little dated. It needs a bit of work by the user, i.e. the staff user, to get it going, and it will only have weak integration with your VLE. So we had a review of that a couple of years ago here at Hull. Again, partly driven by our desire for Cybersecure Essentials accreditation. that our ICTD department working on having a Unix VM running with WebPA on it, where we didn't have the Unix expertise anymore to know if it was safe or not. So although it was free and it was inside our firewall, we had to replace it with a paid-for solution. So we reviewed several ones available, and there are several now, including CATME, PeerAssess Pro, Peer Scholar, peerassessment.com, Spark Plus, and WebPA itself. In the end, having looked at costs, ease of implementation, integration with the our own Canvas VLE, we adopted Buddycheck. Buddycheck gives you some nice complexity, and at the same time, it's complex. So it's nice in many respects, but not necessarily an easy fix. So the kind of thing it will do is give you ways to review the outputs from students, so they can start to score each other, these kind of scoring profiles, and it will give individual students their scores against different activities. So on a given criteria, like how far they contribute to teamwork, the student gets a profile like this, which says that this student, for the self, with the fair share of team's work, reasonable quality. If you got a grade 5, if you do more or higher work than was expected, or grade 1, doesn't do a fair share of the team's work. So they kind of score each other on these kind of scoring profiles on what they've done in a team project. We used it several times now for the last 2 or 3 years. So my colleague John he does the team part of our personal development module that I share with him. I think so last year I took 46 students on that with 43 teams, which is quite for us a big module. And for the university it'd be a small module. For some universities that'd be a huge module. So it's partly a perspective issue, but it's quite a big thing to manage. We have a small staff base. There's 2 academic staff on a module, 2 or 3 demonstrators for the labs. We got them to a job search, a skill audit, a CV, and a SMART plan as part of a personal portfolio, and a team project to build a prototype open software. They spent a week team forming. 3 weeks later, they presented what they developed and the various checkpoints to show how they were developing a solution. And at the end, we did a personal reflection on their team role, online quizzes to look at what we're doing in terms of the for wider module issues. And we've built things like a mock-up of an attendance monitoring system, which is based on our campus one. We use Seats, but they mocked it up as an alternative way to present the data to students, so they could get a useful way to interact with that from a phone rather than on a student card. Again, the students' satisfaction with this was good generally. The team project was great for helping build teamwork skills. It was a lot of fun and a great way to find friends and get accustomed to university life. So we use that module now as a way to get students to engage and help retain them in our course, which in computing is still an ongoing issue. In Design and Deploy, a similar sort of module. It's a bigger one. It's two semesters long, 40 credits. They get software project briefs with a fixed brief for the teams. They begin to work on that. They reflect on their team roles. Again, this year, it's 29 teams. They have 4-stage checkpoints where they do reports on their developments and their ideas. They do inline peer review. So every 3 or 4 weeks at the checkpoints, they do a peer review of each other, so we can start picking on problems early on. Have guest lectures as well to talk about what they're doing, to give that context. And again, they like the approach, they like the idea of having guest speakers, they like the practical approach of it. And because we're working in teams, we get to do Scrum-based projects. So they work as a development team. So they're doing these 3 to 4 week sprints. At the end of each sprint, they do peer assessment so we can understand how they're getting on. So here you can see about the way that teams engage with the different levels. So this is creating an alpha version of the system, a beta version, the live version, and a file submitted version. And the grades in here, the X's are mark profiles. So initially, the marks were sort of towards the sort of 2.5, 3.5 range. As they learned from that, when it progressed, profile skews more and more to the right, apart from where some teams dropped out. So it gives us a way to contextualize team activity, drive that team process, and at the end of the day, to then be able to give them individual marks. So we get this linear relationship between the the marks on average for the team project activities at the start. I get them to work on that reflection side using the Buddycheck tool to see how we're all doing. So what they found was that Buddychecks, so every 3 to 4 weeks, made them participate more because they knew that their teammates were telling each other, student A has done a lot, student B has helped quite a fair amount, student C hasn't done much at all. And so you can see that and share that transparently, progressing through, it encouraged them to engage. It got them to consistently be working and engaging with the group. So again, it avoids that situation where people are freeloading or dropping out. And again, interestingly, some of them found that the feedback ratings were matching their own, or even better than they thought they were doing themselves. So it gives them that self-reflection as well. And again, we say, student satisfaction on this was, again, 4.3 out of 5, with 5 absolutely satisfied. So generally speaking, they're very happy with this sort of approach. In digital disruption and innovation module, they progressed from that in the same teams, but this time we're now creating business models. We've used business plans, pitch investment. So you've ever seen The Apprentice? It's a bit like that, but in this case, they're able to work on proposing, developing a software idea. Again, it links with the honours project we do at that stage as well. What the extended honours thought of this is that the way this curriculum works now is helping the students engage with the curriculum more effectively now. And it's more authentic in terms of mapping the student activity as a student into what we'll do when we graduate and go on to work. But I think these backbone modules, so these large modules throughout the 3 years of a course, give them the skills to go on and develop. So particularly the teamwork aspect, where they can learn about building that knowledge and skills base incrementally, to learn about it and get that support from their peers in doing that. So having the teams work at those 4 to 5 builds confidence. Peer review too, it seems to be useful. Let's understand what people will assess you by. And again, one of the ideas here is that they learn about how we assess them, because early on they have to try and assess each other. So it's just helping them on that and help them develop a point where when they graduate, they've got the competency to go off and work in teams on projects. And it's something we have good feedback to us from employers, but our students are useful when we leave. They've got technical skills and these important transferable skills like teamworking. Again, by having the dashboards on what teams are doing, we can identify where the problems. We've had a sort of tension tag now. We can see if there's an issue in the team, so maybe someone isn't pulling the weight, apparently, we can get that to flagged up and look at that team and chat to that team and try and deal with it. Having some problems, again, students have said they feel uncomfortable sometimes giving some of their peers in their team a low score, even if they've not been contributing as much. And again, it's just about awareness that professionally you need sometimes to be harsh. So it's being fair but reasonable. And again, as that issue also we've said some compulsory online retrospectives we've done in now to try and get them to do that in a more structured way. So got to think about retrospectives in terms of what's going on in the team projects. So what I've liked, learned, lacked, or longed for in the module. So get them to look at this from a retrospective perspective. So we do a Buddycheck peer review and a team retrospective on what's happening in the team and the development at these 4 checkpoints through the module. So you can look at what we liked in terms of the previous 3 weeks. So in-person meeting example, the chats and the team chat. What we've learned about the need for clarity, communication, ensure basic requirements are met. What we've lacked, like deadlines for the team or priorities or backlogs, and particularly things like workflow between members. And then probably what we're longed for, some more of the communication aspects in the team, which again we do give them a framework for. And by experiencing the issues as they progress through a degree, by the time we get to the level 5 and 6 or 7 modules, they should have developed the skills better so we can address that later on. So these are team projects. We've been working effectively for many years. Buddycheck gives us a new mechanism to get the students to grade each other. And because of its So ease of setup, we can use it at various checkpoints now. So we do it as a formative activity every 3 or 4 weeks, and at the end of the module, do it to help grade each other. So Buddycheck gives us a detailed feedback now and dashboards on student activity, which has helped improve peer assessment and peer activity. It's helping us develop students' teamwork skills. That's going to be critical for them as gone to software development of whatever format. So being augmented this year, the Buddycheck reviews of team activity alongside the retros of the actual sprints of agile development. So again, they can improve their team activity by looking at how we're doing for a retrospective every 3 or 4 weeks. That's some issues still. I think disputes and ensuring peer assessments are fair and honest is an issue. And again, one of the issues with that is how we can make them record evidence, like minutes of meetings, using things like Git and document management, serve as an evidence base to demonstrate who's actually doing what in a team. And we're working on that in the future, so it's still a work in progress, as most of these things are. Looking at finding these processes and tools to be more effective in supporting the students. So that's a brief outline of how we're dealing with teamwork here at Hull. So thank you again for my third and final talk today, and I'll hand back to James.
Thank you very much, Neil. That was again wonderful, really well done. Again, enlightening. Has anybody any question for Neil now, please? Any questions or comments or something like that?
You know him?
Yeah.
Yes, Margaret, yes.
Yeah, I was thinking, I'm just thinking in the past when I was doing group work, occasionally you've got a situation where a group totally broke down, particularly where you've got one person refusing to cooperate. How do you handle that in that situation?
Well, one of the ideas really is to try and pick it up early. So that's why we have these checkpoints now every 3 or 4 weeks. So a team in the past could sometimes mask that. The person might drop out, the team don't tell you. Whereas because at week 3, they do a Buddycheck assessment where we can see the scores. So if anyone's got zeros in all the scores for the team, we know that person isn't doing anything. So we can check with the team what's going on. And if there's a problem there, we can then talk to that person, talk to the team and see. I mean, ultimately, if someone says they refuse to work in a team, but this is a team-based activity, it's a team-based assessment, and that's also a competency for us, or learning outcome in the old terminology, they do have to engage with it. One thing I tend to do, I think John has got a similar approach now, is to ensure that projects are designed so usually there's several things they're creating as a deliverable. And if there's someone who really doesn't want to work with a team, they can be given something where they can essentially work separately to them, but informed by it. So it might be documentation. So the team say, well, if you want to come and see us and work with us on developing the software, this is the software, can you document a guide to using it? And it might be, again, if they get a lower score for not supporting the team generally, but they wouldn't get 0 because they are doing something contributing. So that for workarounds, if someone absolutely refuses to engage, but generally speaking, people are more willing to now. And again, in a way, it's easier now because of all these online tools. So it might be if someone doesn't want to come in and see people, that's okay. You can do it through Teams. So we do a module with team sites. So the module has a team site, and every team has a team channel. So they can communicate via chat. If you want an online meeting, they can do. So we're not saying people must get together. They have to like each other, but we do have to cooperate to an extent because that's what you do. And again, it's one of these real world skills. You know, like I was saying, in your institutions and your employers, I'm put in situations with colleagues I have to work with. I may not like them. I may not always think they're competent, but I've got to make it work because it's not my choice. They're there, they're employed. And it's the same as students. I say, well, you're not choosing to work with this person. We're telling you to work with them because it's a competency of being a developer. But I think the benefit now is we can pick this up earlier and we can offer them other routes to do it. So 20 years ago, they had to meet up and meet personally to do things. Now we can do it remotely. They can share code on Git. They can share documents on OneDrive or Google Docs. They can do a huge amount of work now and never meet, as many of us do. Again, this event itself is a good example of that. We don't have to meet up physically anymore. We can do it remotely. And again, so I think it's just having those options and being flexible as well. So tell the students, don't do nothing, come and see us. If there's a problem, let us know. If there's really a relationship breakdown, that's slightly different. I mean, if there's cases of, you do sometimes have it, if there's 2 or 3 people essentially maybe bullying somebody else, then we refactor the teams, move them around. But if you find out that in week 2 or 3, you can do it. It's when it gets to week 12 and we say, oh, I've not done anything because the team wouldn't let me. That's too late. But again, by having Buddycheck there in week 3 and week 6 and week 9, we keep checking that there's not a point where someone is dropping out. If we get to and say, actually, I don't want to do the course now, I'm not doing anything, that's different, obviously. But yeah, it's just really that chance to catch up and monitor it in a scalable way again, though. So I can't do that with 200 students normally. With Buddycheck, I can look at the profiles. If I see any zeros, we know that team has a problem.
Thank you very much, Neil. And I just triggered a memory when I started. So this is more than 2 decades ago. There was the instance where you thought you were checking the whole thing around about week 4, week 5 out of the 12 teaching weeks. You discover a few students who were not really playing ball, and the trick that one had to use at the time was the groups of students who were not playing ball. You put them all together and form a new group out of them, and then you discover they all tend to work out well at the end of the day, and that seemed to work. And but I think because it is like a teamwork, and you are, in fact, that is what one of the things I've said is allowing self-selection to form teams leads to great problems sometimes. Okay, it really does. But when you start off the team by selecting them, if there are problems and you come with commands, you come with direction, they take the command. But if they self-select and it's leaderless, and a lot of problems can come up and you'll not be able to control it. But it's really great insight you've given us into the practice here this afternoon there. It's great. Thank you very much.